In this video, we are going to see a procedure to solve problem based on convolution. So convolution is nothing but a process to get an output if an input is given, provided I know impulse response of a system. So graphically it is represented like this. We have a system and precisely it should be a linear time invariant system whose impulse response is known. Which is h of n. So to this system, if I give the input x of n, I will get the output y of n. Mathematically, I can consider this as y of n equals x of n convol. This is a symbol for convolution, h of n. And the formula for this is y of n is nothing but summation k varies from minus infinity to infinity x of k into h of n minus k. Now from this convolution sum formula, we are going to derive a procedure which we need to follow to solve problem based on convolution. So if you see properly, this is a convolution sum formula where two signals are getting multiplied. So I'll consider this as x of k, and another signal I will consider a shifted version of h of minus k. So the first step in a procedure is replace the signals which are x of n, which is input, and h of n, which is the impulse response of the system. So these two things are always given. So what we'll do the first step? Replace the signals x of n, which is input, and h of n, which is the impulse response of the system, by some other variable name as an independent variable, meaning x of n will become now x of k and h of n will become h of k respectively. So here we haven't done anything great. Instead of n, we replace an independent variable by k. So that will be our first step. Remember, I am just taking this formula as a reference. So x of k is obtained now. Now second step, h of k, we can take x of k also, but since in this formula we have taken h of n minus k, hence what we will do in the second step, we will take a time reverse version of h of k. So take time reversal of h of k to obtain h of minus k. The second step is getting h of minus k. So we have reached up to this h of k and h of minus k. And now there is n term which is dependent upon this y of n. So now what we are going to do, this h of minus k, we are going to shift by n. N may be positive or negative. So time shifting of h of minus k by amount n need to be done in the step 3. So what we are going to do in step number 3, time shifting of h of minus k by amount n we will do to obtain h of n minus k. So we'll get our next term is h of n minus k. Now over here there are two shiftings we can get. Either it will be a delayed version of h of minus k or advanced version of h of n minus k. So we will see one by one. So now I'm focusing in h of n minus k. Remember, this h of n minus k will obtain by shifting h of minus k. So let's consider I have one random sequence like this. Having the value 1, 2, 1 and 3 for 0, 1, 2, 3 instant. I'll consider this as a k-axis and this sequence is h of minus k. As I said earlier, this n will decide whether it is time delay or time advance. So if n is less than 0, then I will get these terms are negative. So remember, whenever the shift is a negative, that is a time delay. Now in case of a time reverse signal, the time delay will be towards left hand side or towards minus infinity. So if I want to shift this by the amount n where n is less than 0, it may be like this, and let's take a minus 1 because we have to shift it by only one instant at a time. So if n is minus 1, I will get a signal shifted by 1 unit towards left hand side, towards minus infinity. So I will get a signal like this. It will start from minus 1, 0, 1 and it is end on 2. So I will get the values 1, 2, 1, 3 and this sequence will be h of minus 1 minus k. So what we have done over here, this h of minus k is shift to this side by 1, which we call as time delay. Now let's see for a time advance. So if I'm having n greater than 0, so we call this as a time advance. So if I take this n greater than 0 and one by one if I do the shifting will look like this. So I will do the shifting for n equal to 1. So it will get shifted towards right by 1 unit. That is what the positive shifting, which we call as the time advance. So signal will start from 1 and it will end at 4. So over here the shifting has been taken place towards right by 1 unit. Hence, if the positive shifting is there, the advancement is like this towards right for the h of minus k. So this we call as the time advance. And we have to do this shifting by 1 unit at a time. So I'll say time shifting of h of minus k is done by taking one value of n at a time. So whenever we are doing a shifting, now we are ready to get y of n for every shift of n. So the fourth step is for every shifting step of h of minus k with value of n, we need to apply the convolution sum formula. Which is y of n is summation k equal to minus infinity to infinity x of k h of n minus k. So for every value of n, we will have this formula need to apply again and again. And in the last, for verification purpose, suppose x of n is the input signal having m number of samples and impulse response h of n with n numbers of samples, then convolution of this take place to get y of n. It will have m plus n minus 1 numbers of samples. So this is the most important thing as far as verification is concerned. So x of n, if m are the number of samples, h of n with the n number of samples, then y of n will have m plus n minus 1 numbers of samples. Example, suppose I am having x of n with number of samples 4 and h of n with number of samples 3, then y of n will give you 4 plus 3 minus 1, which is nothing but m plus n minus 1, nothing but 6 samples. So for every problem we can check whether the answer that we are getting having the same number of samples or not. Once again, one more point is there as far as verification is concerned, and the point is this. We can check the convolution result by solving some simple matrix formula, and that says whenever we are having a sequence x of n and h of n, I can write like this. For example, x of n I will write with the samples in this column, and h of n I will write the samples in this column. Let's take an example where x of n is number of elements are 4 and h of n with the number of elements 3. So I'll consider here x of n having the sample points x of 0, x of 1, x of 2, x of 3, and over here samples are h of 0, h of 1, h of 2. So what we need to do, whenever we write this, what we'll do, we will multiply this x of 0 with h of 0, h of 1, h of 2, so it will give you x of 0 multiplied by h of 0. Then we have x of 0 multiplied with h of 1, x of 0 multiplied with h of 2. First row is over. Now let's go to the second row. So here x of 1 getting multiplied with h of 0, x of 1 multiplied with h of 1, x of 1 multiplied with h of 2. Second row is over. Third row, x of 2 multiplied with h of 0, x of 2 multiplied with h of 1, x of 2 multiplied with h of 2. And final row will be x of 3 into h of 0, x of 3 into h of 1, and x of 3 into h of 2. So basically here I am getting this matrix kind of thing, and here I can segregate the terms like this. And in the end, if I check, I will get terms like this. X of 0 into h of 0 is the first element. Then I have x of 0, h of 1 plus x of 1, h of 0. Next term I will get is this, x of 2, h of 0 plus x of 1 into h of 1 plus x of 0 into h of 2. So 3 terms I got, 1, 2, 3. Fourth term will be this, x of 3 into h of 0 plus x of 2 into h of 1 plus x of 1 into h of 2. And remaining 2 terms are this, x of 3 into h of 1 plus x of 2 into h of 2, and finally the term that I will get is x of 3 into h of 2. So I will get this as y of n. So let's count the number of terms. 1, 2, 3, this is 4, 5 and 6. So I'm getting 6 terms. So the formula m plus n minus 1 for getting a number of terms in y of n is satisfied. Now we need to find out where will be the origin of the y of n. For that I should know where is the origin of x of n and h of n. For example, suppose I'm having a h of n origin at this point. So here I have mentioned h of 1, but still we can consider even if the origin is given over here, how to solve. Okay. So similarly over here also, let's take a origin is somewhere here. Don't get confused with this 2 and 1. It may be any number, and I consider suppose origin is over here. Here also origin is here. So the intersection of this and this origin is result into this third term, because there it is intersecting. So I can say now this is a third term where two origins are getting intersected. Then the third, 1, 2 and third point here, this will be the origin for y of n. Anyways, most of the problem we will solve where we will verify our answers with the normal convolution sum formula also. So this is one of the technique to check whether we have done a convolution with respect to a proper and right method or not. Okay, but this method you have to just use for the verification purpose. Otherwise, you have to solve it by shifting every signal by a 1 unit and doing or using this convolution sum formula. Once you got this, you can verify number of elements and what should be the number of elements and origin should be locating with the help of this particular exercise. Thank you.